Okay, so let's have a quick, easy example on the thought process behind solving a linear inequality. Okay, so for the most part, I can treat solving linear inequalities just like solving linear equations. I'm going to try and isolate the variable. I'm going to simplify it beforehand if I need to. And then I'm just going to pay attention to my cardinal rule. I can do whatever I want to one side of the statement, so long as I do the same exact thing to the other side of the statement. So if I want to add 10 to one side of the equation, I got to add 10 to the left side of the equation. If I want to subtract 18 from the left side of my inequality, then I need to subtract 18 from the right side of the equality. All that holds true. The only thing I've got to pay attention to is if at any point I end up multiplying or more likely dividing my inequality by a negative number, I've got to turn my inequality symbol around. I got to flip it. Okay? So for us, if I want to solve for x and I want to find my solution set, all the x's that make this statement true, I see that I am currently multiplying it by 7 or negative 7, and then that minus 7x term is being added, is having 6 added onto it. So if I want to solve, usually we get rid of adding and subtracting first, and so that's all I'm going to do is I'm going to subtract that 6 from the left, so I'm going to subtract 6 from the right. Now I can subtract any two numbers all day long. It's not going to make any impact on my inequality symbol, so I'm going to keep this as less than or equal to. And then otherwise, bring down that negative 7x. 34 minus 6, I hope, is 28. And then once again, because that's multiplication, I'm going to divide both sides by whatever I'm multiplying by, in this case, negative 7. But as I write, divide by negative 7 on both sides, that's my red flag. I'm dividing by a negative number, and that's the only thing that matters. And so in order to sort of maintain the truthiness of my inequality, my less than or equal to has to become greater than or equal to. And then the negative 7's cancel. I have x is greater than or equal to 28 divided by negative 7 is negative 4 on the right. Okay, so what's my solution set in interval notation? Well, if I were to graph this, negative 4 would be about right here. So everything greater than negative 4 would be to the right. And because it's or equal to, in this case, we can include negative 4. We give it a square bracket. So left to right. What's my solution set? It's including negative 4, comma, through or up to positive infinity. Infinities always get parentheses, and that's ball game. My solution set is everything from negative 4 to positive infinity.